I'm Carl. I'm a safety and security architect at Codasip, and I'm going to do a very brief introduction to compartmentalization and CHERI. How do we use CHERI and what advantages it can give you? So if you take a typical application these days, whenever we're developing applications, it used to be, on simple systems you might still write the whole application yourself. Actually, a more complicated systems, or more typically these days, you pull in a lot of third-party libraries, a lot of open source stuff typically, and we glue them together effectively. You do a lot of glue logic in the app itself and call libraries and write the code for the specialist bits you want. Now, the problem with this is that some of these libraries, you probably pulled them from GitHub or something like that. Some of them are well known, some of them not so well known, depending on what you're doing. And the big problem you have is if you don't know how well the code has been written for security, for instance. How much trust can you put in any of these libraries? And it's difficult to evaluate this sometimes. You can look at them. Typically, you look at how many contributors are contributing to them. You might want to look at how well they're tested, what the test framework is, which companies are involved, and that generally gives you a reasonable feel of the quality of it, but not always. And as we know, there's often security bugs appear in libraries, and you'll see CVEs commonly put out for security vulnerabilities that are found. So how can CHERI help? Well, within CHERI, we can use the low-level hardware constructions to create higher-level software security abstractions. And one of those is compartmentalization. And with compartmentalization, we can start to isolate bits of software running on the system and limit what it can do. And this is all based on the security principle of least privilege. So we only give access to a bit of code to what it actually needs to do and perform. So within CHERI, we can do this to a very fine scale. CHERI can protect memory down to, single bytes. So protecting a library or even a function within a library is completely possible. And one thing CHERI design goals is to make this efficient as possible as well. Or within an application, we can isolate off various libraries and give them very defined interfaces and restrict what memory they have access to as well. So they can't overwrite something, from the main application itself. So gives a much more secure system. And you can extend this a lot further as well. So small system, you've got apps and libraries. Bigger system, then you obviously have operating system in here. And we might have multiple applications. And in which case we can start to constrain things even further. We can create compartments around, bigger chunks of software, and then small within it. And you can do this at arbitrary scale effectively. Obviously, the more you do it, there is a performance impact and memory impact, but it gives us a lot more flexibility in what we want to do. And in fact, if we take CHERI to its extremes, typically in a system, we have the operating system, which is separated by exception levels. So, for instance, this might be running in a supervisor mode of some form. Apps running in a user mode. Within CHERI, we can actually remove these modes, and we can put these in compartments here, another compartment here, another compartment. And actually, in something like a real-time system, we can remove the overhead of skipping between these different exception levels and actually start to treat them like function calls, so we can get a performance benefit there as well. But this sort of thing CHERI allows us. It's a lot of flexibility, but a lot better ways of protecting our software.